Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. This is our 9th lecture. In previous lecture we have discussed numericals on Newton-Raphson method and numerical solution to algebraic equation. So today we are going to discuss the Cramer's rule to solve algebraic equation and Gauss elimination method to solve algebraic equation. So very first we want to discuss this Cramer's rule. So this Cramer's rule is nothing but the concept of determinants is used to solve the algebraic equations. So here there is a set of equations, say for example a11 x1 plus of a12 into x2 plus of a13 x3 is equal to c1, and second algebraic equation is a12 x1 plus a22 x2 plus a23 x3 is equal to c2. The third algebraic equation is a31 x1 plus of a32 x2 plus of a33 x3 is equal to c3. So now this matrix is written in the form of A matrix A into matrix X equal to matrix C. Now, where A is the matrix of coefficients for three equations 1, 2, 3. Let matrix A is nothing but the matrix of coefficients a11, a12, a13, a21, a21, a22, a23, a31, a32, a33. This is matrix of coefficients from this set of algebraic equations. Now let's deal with the determinant of matrix A. So this determinant is written as a11, a12, a13, a21, a22, a23, a31, a32, a33. So this is determinant of the coefficients of variables. Now we can simplify this determinant. This determinant can be written as a11. So if we take a11, then we can eliminate this column and eliminate this row, and we find the determinant of rest of the elements a22 into a33 minus a23 into a32. So this is multiplied, this is a major diagonal multiplied minus multiplication of minor diagonal minus of now this term a11 is over. Now we move for next term a22. So now taking a12 minus a12, so this column is eliminated, first row is eliminated, and rest of the numbers or coefficients are multiplied. a12 is multiplied with a33, a21 into a21 into a33 minus of a31 into a23. So these are multiplied in this. So then coming to the next element, a13. So this plus of a13, eliminating this last column and first row into multiply this into this, then a21 into a32 minus of a22 into a31. So this is the method to find out determinant of given matrix. So this determinant is used in finding or in solving these equations. Now after this we are going to find out the other determinants replacing columns of this determinant. So once we replace first column, then we replace second column, third column by the coefficient, the constants on right hand side of this equation. So here we find three different determinants, that is C1, A12, A13, C2, A22, A23, C3, A32, A33, one determinant. Then we find another determinant. So this we call as a determinant A1, say. Then determinant A2 can be obtained just by replacing second column by constant C1, C2, C3. So here we take A11 and then A13, A21, A23, A31, A33. So this is second determinant. Third determinant A3 is obtained by replacing third column. So this is A11, A12, C1, A21, A22, C2, A31, A32, C3. So here we can find out determinant A1, A2, A3. Then after finding determinant values of these determinants A1, A2, A3, so to find out x1, we can have this equation as A1 divided by D, and x2 is equal to A2 divided by D, and x3 is equal to A3 divided by D. So this gives us the values of x1, x2, x3 by using Cramer's rule. Now let us simplify one problem, numerical. And to get the values of x1, x2, x3, let there be a equation point 3x1 plus of point 52x2 plus of x3, which is equal to minus 0.01. So this is one algebraic equation. Second algebraic equation is 0.5 x1 plus of x2 plus of 1.9 x3 is equal to 0.67. Let it be second equation, algebraic equation. And third algebraic equation is 0.1 x1 plus of 0.3 x2 plus of 0.5 x3 is equal to minus 0.44. Third algebraic equation. So it is expected to solve this set of equations, find out the variables x1, x2, x3 using Cramer's rule. So to find out solution to these algebraic equations, first we have to find out determinant P, determinant A1, determinant A2, and determinant A3. So first, to solve this solution, we'll have the determinant D. Determinant D is nothing but 0.3, 0.5, and 1. Coefficients 0.3, 0.5, coefficient of x3 is 1. Then 0.5, 1, 1.9. Coefficient of x1, coefficient of x2, coefficient of x3 in second equation. 0.1, 0.3, 0.5, coefficients of third equation. So we can simplify this and we can get solution to this. So determinant can be obtained here. Nice. Point 3 into minus s. So rest of the determinant we can take this as another determinant, or we call it as a minor, into 1 into 0.5 minus 0.3 into 1.9 plus of minus of 0.5 into 0.5 into 0.5 minus of 0.9 into 0.1 plus of this 1 into these two we multiply, so 0.5 into 0.3 minus of 0.1 into 1. On simplification, we get this determinant as minus 0.0022. So this is the value of determinant D. So now again taking determinant A1, A2, A3, we can get the determinant A1, say. Determinant A1. So in place of first column in this determinant D, we substitute these coefficients C1, C2, C3. So here minus 0.01, 0.67, minus 0.44, 0.5, 1.3, 1, 1.9, 0.5. So this is determinant A1. So simplification of this is minus 0.01 into 1 into 0.5 minus 0.3 into 1.9 of these two, minus of 0.5 into 0.5 into 0.67 into 0.5 minus of 1.9 into minus 0.44 plus of 1 into 0.67 into 0.3 minus 1 into minus 0.44. On simplification, this we get as it as 0.03278. So this is A1. Now coming to next, we get A2 as 0.3, 0.5, 0.1 minus 0.01, 0.67 minus 0.44, 1, 1.9, 0.5. Now this A2 determinant can be simplified as 0.3 into minor of this 0.3 is 0.67 into 0.5 minus of 1.9 to minus 0.44 minus of minus 0.01 minus of minus 0.01 into 0.5 into 0.5 into 0.5, then multiplying these to 1.9 into 0.1 minus of 1.9 into 0.1 plus of 1 into eliminating first row and last column 0.5 to minus 0.44 minus of 0.67 into 0.1. On simplification, A2 we get as 0.0649. Then we can find out A3, which is determinant 0.3, 0.5, 0.1, 0.52, 1.3. So just this constant coefficients of constant terms are transferred to the third column, that is minus 0.01, 0.67, minus 0.44. as we have seen in first here. So this constant column just gets shifted to second then third. So here it is in second and here it is in third. So in the same way we are going to get this. This is equal to 0.3 into 1 into minus 0.44, 1 into minus 0.44, minus of 0.67 into 0.3, minus of 0.52 into 0.5 into minus 0.44, 0.5 into minus 0.44, minus of 0.7 into 1, 0.67 into 0.1, plus of minus 0.101, multiplication of this 0.5 and 0.3 and multiplication of 0.1 and 1, bracket 0.5 into 0.3 minus 1 into 0.1. So on simplification we get A3 as minus 0.04356 A3. Now we'll collect this information. The value of determinant D we obtained as minus 0.002, minus 0.0022. Then we obtained A1. A1 value was 0.03278, 0.03278. Then determinant A2 we obtained as 0.0649, 0.0649, and determinant A3 as minus 0.04356, minus 0.04356. Now we can find out x1. X1 is equal to A1 divided by D. A1 is 0.03278 divided by D is minus 0.0022. So this gives us as minus 13.9. Then variable x2 is equal to A2 divided by D. A2 is equal to 0.0649 divided by minus 0.0022. So this x2 works out as minus 29.5. Then x3 is nothing but A3 divided by D. A3 is minus 0.04356 divided by minus 0.0022. So answer is positive 19.8. Only thing is one should know how to form determinant D, then determinant A1, determinant A2 and determinant A3, and to simplify these determinants, if it is known clearly to know or to find out determinant D, A1, A2, A3, then it's very simple to find out x1, x2, x3. So to know this, A1, A2, A3 are formed from determinant D, where the columns are replaced by C1, C2 and C3, which are the constants in this equation. So very important thing in this Cramer's rule is that one must arrange these equations, equation 1, 2, 3, in such a way that, so very first, if there is a variable x1, in all the equations variable x1 should be there. So this is very important. Then second variable, if it is x2 in this first equation, then in all the rest of the two equations x2 must be there. Then if it is x3 here, then x3 has to be here in all three equations. So in this way, first of all, we have to rearrange. So for example, equation number 2 is given like this: 1.9 x3 plus of x2 is plus of 0.5 x1 minus of 0.67 is equal to 0. So instead of giving this equation 2 in this usual manner, if it is given in this way, then we have to rearrange. So x1 has to be taken at first, 0.5 x1 plus of x2, then plus of 1.9 x3, and this 0.67 minus 0.67 has to be transferred on right hand side, and 0.67 we have to write. So all these equations must be in the standard form, where very first variable is x1, then second is x2, third one is x3. If, say for example, in any of the equation one of the variable is missing, say x2 plus of 0.5 x3 is equal to 76. So here x1 is missing, so we have to write x1 with 0 coefficient, 0 x1. Then now it is in standard form. Then we have to rearrange these equations in this way. And then we have to form determinant D, determinant A1, A2 and A3. So it is very important to note this here the variables x1, x2, x3 must be in same order. It is not compulsory that always there must be x1 at the first. So you can take x2 at first, then x1 and then x3, but all the equations should contain x1, x2 at first, then x3 at second and x1 at last. So it means that the x1 should be in all equations at first, or x2 should be at the second, or x3 should be in the third column. So this is how you have to arrange these equations in standard form. Then only the solution will lead to the accurate answer. Else if you are going to put the equations in the random fashion, then that will not lead to the accurate answer. So today we stop here with the Cramer's rule, and tomorrow we will see the Gauss elimination method. Thank you.